looking at solving systems by substitution. Now, if we're going to solve a system by substitution, the first thing is we're just going to need to know what that word even means. Okay, so what does the word in math substitution mean? Sam?
Isn't it like you trade a number for another number?
Right, we're trading one number for something else. The two things are the same.
So basically, if I solve this, you would get your answer and put it back in?
More than that, we have more substitution than that. Okay, so I keep asking you this question, and you guys are all annoyed at me, but it really comes into play today. What does this mean?
That x is equal to 2.
X is equal to 2. What does x equals 2 mean?
That it's
If you plug it in to add, wait, I know this. So you can take the 2 and you plug it into like 29 times.
If we plug in the value for x, what happens? It will make the equation true. Right? It says that x is holding the same value as 2.
Oh, so we're doing.
And if I plug it back in, it will make a true statement. Okay, so anybody cook in here? Anyone like to cook? Okay, so let's say that you have a recipe and it calls for butter. And you decide that you don't want to use butter, so you're going to replace it in the recipe with margarine. Right, so the recipe calls for a cup of butter. Does that mean you're going to put in a cup of butter and a cup of margarine?
No.
No, like if you're cooking cookies, you're going to get really flat melted cookies. Right? What do you do if you're going to substitute in margarine for butter? You don't do the butter. The butter goes away. Okay, the margarine goes in its place. So something has to go out for something else to go in. And that's exactly what we want to happen today. So I have some steps written out for you, but I want you to understand this statement here, just like I've sort of said before. These steps that we're going to go through, it's not like if you go to another teacher, they're going to say, oh, you're wrong because you didn't circle something. I am trying to give you some visual cues that will help you with the substitution. They're not a requirement for you to get an answer right. All right, but if you come up to me and you say, I have no idea what to do, I'm going to say, well, did you circle and underline what you should have done to get those visual cues to happen? So I'm going to actually look at the problem underneath and still talk about the steps at the same time, okay? So if we look at this first problem over here, step number 1 says that we want to find a variable, either x or y, or whatever variables are in the problem, with a coefficient of 1. What's a coefficient?
Like the x.
The x is the variable.
Oh, no, the coefficient is the number right before the x.
The number in front of the variable. So if we want a variable that has a 1 in front of it, how often do we actually see that 1 sitting there? We don't, right? So we're really looking for a variable that has no number sitting right next to it. Okay, so we're looking for a variable with a coefficient of 1. So if I look at this problem right here at number 1, where do I see a variable or variables with a coefficient of 1?
Y.
Both of the y's have a coefficient of 1. Now, if there's a choice, you just need to pick one of them. There isn't a right or wrong answer. You just need to pick one of them. So which one as a class would we like to pick today? The top one or the bottom?
Bottom.
Top, sure?
Bottom.
Okay, so we're going to circle the top one. Ooh.
So we circle the y, right?
Yep, that's step 1, is just to circle that y, because it's a variable with a coefficient of 1. Step 2 says that we are going to underline what it equals. So what does y equal?
2x.
2x. So I'm going to underline the 2x that it equals. Now, if we go back to this same statement over here of x equals 2, that same idea, what does y equaling 2x mean?
4.
No, what does it mean?
What it equals?
I mean, it does say that y equals 2x, but what does that mean?
It means you can plug in
Means y equals 2x.
2x for the y.
We can plug in 2x for the y, and it will be a true statement. Y and 2x are the same thing. Right? Just like having a $10 bill and two $5 bills are the same value. They hold the same amount even though they look very different. So then step 3 says, look at the other equation, the one that we haven't touched yet. So we're going to look at the other equation. And we are going to cross out the same variable that we circled. So what letter did we circle?
Y.
Y. So what letter are we going to cross out?
Y.
Y. So we are getting rid of the Y.
So it's going to be 2x.
Because when we substitute, something has to leave. Okay? And something else has to go in its place. So what we underlined,
Goes there.
we are going to put there instead. Because Y and 2x are now the same thing. Why? Because that's what this equation told us. Yeah?
It's like the solving for y, or the...
And this is going to be even easier than solving for y, because now we have a new equation. And the new equation, now I'm just going to write down what I see. 2x equals 6x plus 24.
So then we...
And this is an equation that we know how to solve and get an answer value for.
Can we just divide?
So we minus 2x?
Okay, so let's talk about this for a minute, because this is a common confusion piece.
Minus 6x.
Are these variables on the same side or opposites?
Opposite.
Opposite. So my students agree that they want to use the opposite sign. Okay, how many of you want to subtract the 2x?
Well, we can't, because then it'll be nothing.
Okay, so you can, mathematically speaking, right?
You can.
Move the smaller variable. That's the rule I've been taught.
Use
Okay, but if we subtract this 2x, we end up with a 0 over here. And then we just have to start moving back that direction. So there's also kind of a rule. Okay, but remember, my rules are really just more guidelines. It's a good idea not to empty a side. Don't leave a side with nothing, because then you just have to move stuff back over there. It's extra work. Okay, so instead of moving the 2x, which would make this side empty, we'll move the 6x.
So negative 6x.
Okay, so now I realize some of you are like, yes, I definitely remember this. I can solve it. Go. Great. But just to make sure we're all on the same page, when variables are on opposite sides of the equal sign, we move it with the opposite sign.
So negative.
So this 6x is currently positive. Right? We don't see a sign in front of it, so it's a positive value. And we undo a positive with a negative.
Yeah, that's what I thought.
Okay, and I know this might make some of my students uncomfortable. They don't like it, but a negative is the same thing as subtraction. They look the same because they are the same. We read them different based on context.
So it'd be a negative 4.
Okay, so 2x minus 6x gives us a negative 4x.
Oh, I got that.
And I have a 24 left on the other side.
Which x?
Oh, it's good.
Just hang on.
Okay.
I know. My students are like, yes, I love this, but I want to make sure we're all okay and we're all caught up.
Is that easy?
Okay, so this negative 4x is then held on with multiplication, right? Negative 4 times x. If we don't see an operation at all between them, that's multiplication. And we undo multiplication with division.
Yep.
And so we get x equals negative 6. Sweet! My students are like, yes, I got an answer. X equals negative 6. Circle it, I'm done.
No, you have to plug it back in.
Yeah, that's definitely not going to be enough. Because when we solve a system, we set a system as the x and y value. That makes the equations true. Well, I only have an x value. I still need to find a y.
So can't you plug in the y equals
So,
2x?
right? So we're going to have to substitute again. Now, you can substitute into either equation. There isn't a right or wrong answer. Okay, I would substitute into whichever one is easier. I tend to tell my students whichever place you underlined is a pretty good place to plug it back in. So just like we did with functions, right? If I had a function rule that said y equals 2x, and I wanted to plug in x equals negative 6, I would say y equals 2 times negative 6.
So negative 12.
So y equals negative 12. And then there are two ways that we can choose to write this answer. There is not necessarily a better option. Okay, we could choose to write this answer as x equals negative 6 and y equals negative 12.
Do we have to do both, or can we just do?
You have to have both. No. Hang on. Hang on to that thought. Or you could write your answer as -6, comma -12. So you either have to have these two things or this thing, but you don't have to have both of them.
Okay.
Typically in multiple choice, you will only see the ordered pair, but free response, I don't care which one you choose.
I think the bottom one would be easier.
So yeah, I mean, my students tend to think that the bottom one is shorter and less writing, but this is sort of safer because if you accidentally flip-flop these, then you have your X and Y backwards, and that's not good. We sort of see that process in how we're substituting to get a new equation that we can solve.
Yeah.
So let's look at number 2 over here. So if we go through that same process, our first step says to find a variable with a coefficient of 1.
There's 2 of them.
I think there's more than 2 of them.
Well, there's 4 of them.
Right, there's a lot of them.
I meant on the first
X, X, and a Y. Okay, so does anybody have a preference of picking an X over a Y?
No.
We should. There might be some reasoning we should consider. What do you think, Caleb?
I just feel like X would be easier.
Why?
Because I just feel like X.
What do you think, James? You have some things to add to that?
Because it might be harder solving for like Y, because you're plugging Y into X, and you have to find X and Y. So it's easier to just plug X in with.
I think I know what you're saying, but I'm going to change your wording a little bit here. Don't write this down. If we were to pick Y right here. Okay, Jaden's saying this like solving for Y concept. Can I just simply underline what Y equals and then plug it into the one above? No. Does this tell me what Y equals right here? No. All right, so when it doesn't tell us what it equals, it's not a good pick. There is a workaround for it, but the workaround is more work, and this already isn't the shortest problem ever. Right, so if you can find a variable with a coefficient of 1 that already says Y equals or X equals, that's your better pick. So because this one right here, or this one right here, either or, already has it by itself on one side of the equal sign, that's the smarter pick. Does that make sense? Questions about that? Okay, then our next step says to underline what it equals.
So -1
equals
Y?
2 subtract.
What does X equal?
Oh, -2 minus -1.
2 minus Y. So we're going to underline that. And now we're going to go to the opposite equation, the other equation. And whatever letter we circled, we are going to cross out.
So X equals
So what letter did we circle? X. So what letter are we going to cross out? X. So I'm going to get rid of that X.
So it's 2.
So I have a question then. Because there's 2 subtract Y, so what would we do? Would it be negative
Well,
Y?
hang on. Let's just make this substitution first.
Okay.
Okay, so where we scribbled out, in its place, we're going to put a 2 minus Y. Okay, that scribbling out and writing over it is just helping us get that new equation visually, because these do get a little bit more complicated. Okay, not necessarily today, but we want to make sure we're really seeing where we're making that substitution so we can get a new equation. So we have a new equation now that says 2 minus Y equals Y minus 4. Are you okay with that? Now, we have Y's that we need to get together. Are those Y's on the same side or are those Y's on opposite sides?
Opposite.
So if they're on the opposite side, we want to get them together with the opposite sign.
So addition.
Okay, so if we move this Y over here, we would want to add it. Sure. So now we have 2 equals 2Y minus 4.
You add 4.
And then we're just going to start our inverse operation. So we'll undo subtracting 4 by adding 4.
If you divide that, you get 2Y.
We'll divide by 2. 2, or with y equals 3? No.
You have to plug it back in.
Okay, so we have to plug it back in. Where would we like to plug it back in? Sam, where do you want to plug it back in?
Both of them are easy, but I guess top one.
Right, so, I mean, we're both pretty simple, so I just sort of fall back on plug it in where you underlined. So this now says x equals 2 minus 3. Okay, so what is 2 minus 3?
-1. So x equals
So
-1.
x equals -1. How are we going to write our final answer then?
Y equals 3, x equals -1.
Okay, so y equals 3 and x equals -1, or what's our other option?
1, 3.
-1,
3.
comma 3, because my x value has to be first in an ordered pair.
That's fun. I mean, it's not fun, but it's like